Center for Climate Change and Sustainability Studies, Shivaji University, Kolhapur. Quite recently, we have seen, that is the IPCC, they have published the sixth report, that is the Climate Change 2021, the Physical Science Basis. So in that report, they have mentioned so many things they have mentioned regarding to that. And within 20 years, we are going to face the temperature, that is the global average temperature, it is going to increase by 1.5 degree to 2 degree with that respect. At the same time, we are also facing various kinds of disasters. At the regional level also, we are facing various kinds of problems, challenges we are having because of the global warming, climate change. So to discuss that, what kind of the mitigation strategy we should have, what kind of the plans like the developing country like India we should adopt, what kind of adaptation that is basically required. We have organized this lecture series and various scholars we were having. And for the first time, we are going to see, that is at the regional levels, what kind of the regional effects we are having because of the climate change, which are being discussed through the IPCC. In Maharashtra also, we are facing the problem of the flood as well as the multiple disasters at the same time which are being faced. So what kind of solutions which can be provided, what kind of the strategy should be adopted? So regarding to that, we have invited the distinguished speakers from various institutes, that what kind of experience they should share with all of us. And regarding to that, we should frame this plan of action, because the scientists, they have carried out the work and now the ball is in our court. So to discuss all those things, we have started this lecture series. So first of all, I would like to welcome Anil Kulkarni sir, and I would like to I'm very much grateful that you have accepted our invitation for this program. First of all, I would like to share his details regarding to this. He is at present, he is working as a distinguished visiting scientist at the Glacial Center for Climate Change at Indian Institute of Science. Dr. Anil Kulkarni sir, he has started his career in 1979. His glaciology as well as the Cryospheric science journey started in 1979, where he joined a Space Application Center, Ahmedabad. His career took shape as a scientist in SAC, served for 30 years. He acquired a post-graduation degree in applied geology from the University of Roorkee, now known as the Indian Institute of Technology. In 1987, he was awarded a Commonwealth Fellowship at McGill University, Montreal, Canada. He obtained a master's degree in geography, followed by doctorate in geology from Shivaji University, Kolhapur, Maharashtra. Dr. Kulkarni has developed a vast number of remote sensing based methods and models to understand the Himalayan cryosphere. At the Indian Institute of Science, Dr. Kulkarni and his team developed a model based on velocity, slope, and flow law to estimate the distribution of ice thickness. He published around 120 papers in prestigious international and national journals. These contributions make Dr. Kulkarni one of the leading authorities and recently identified in the top 2% of researchers worldwide in geological as well as the geomatics engineering. Dr. Kulkarni conferred with the prestigious National Award in Polar Sciences and Cryosphere in 2014 and the National Geoscience Award in 2009 to recognize his outstanding contribution to applied geosciences. He has also received a Team Excellence Award in 2008 from the Indian Space Research Organization. Now I request Dr. Anil Kulkarni sir to start his lecture. Thank you, sir. You are not audible, sir.
Okay, my apologies for that. And let me start by sharing screen, I guess. Right now, screen is visible, Professor Panak?
Yes, it is visible.
Is it visible? So is it in slide mode now? Okay. Good evening to all of you, and thank you very much, Professor Panhalkar, for your kind introduction, and thank you very much to the Honorable Vice Chancellor of Shivaji University for inviting me to deliver this talk, as well as my congratulations to him for starting a new center at the Shivaji University, which is related to climate change and sustainable development. And this is indeed a need of the hour for us to have such a center. And I'm really congratulating all of you for taking this initiative, which is required. So today I shall talk about water security under warm climate. I will start, mostly I will discuss about the North India and how North Indian rivers will be affected because of the climate change. However, I will also discuss some of the issues which we are facing in peninsular part of India. Okay, so I think I need to do disable. Okay. Now, okay, all right. Is it?
It is not in full screen, sir.
Not in full screen?
Not in full screen.
Is it in full screen now?
No, sir.
No. I don't know how to. Oh. 1 minute, huh? I don't know. Let me see. How to make it full screen. Is it a full screen now?
Yeah. Yes, sir. Yes.
Okay. My apologies for this. Seems like I'm a little bit old-fashioned when it comes to technology. So, what I will be talking today is about the water security under a warm climate. So, if you look into the Himalayas, because predominantly many of you who are sitting in the Kolhapur or that matter in Bangalore or any other place on Peninsular India, if you are not familiar with the Himalayan terrain, but most of the glaciology community, I'm sure, will be familiar with that. So you have a series of mountains into the Himalayas. As you move from south to north, then then there is the first mountain come is the Shivalik mountain range, which is not shown here, which is the southernmost mountain range, and then there is the Pir Panjal mountain range, and eventually there's the Great Himalayan mountain range, which is shown in a red color. There, then Ladakh mountain ranges and Karakoram mountain ranges. So if you look into the Shivalik mountain range, there are no glaciers in this, but there are significant glaciers in Pir Panjal mountain ranges and Great Himalayan mountain ranges. Therefore, if you happen to look into the literature of cryosphere, you see that different glaciers, which are located in different part of the mountain ranges, are responding differently to the climate change. So it is important for us to understand it. But there's also substantial difference into the source of water which is coming into this mountain range. So if you look into the eastern Himalaya, which is Assam or Arunachal Pradesh or Bhutan or Sikkim or part of Nepal, which is predominantly coming from Indian monsoon. That means significant amount of precipitation comes during monsoon. So we in Maharashtra or in Bangalore receive monsoon predominantly in form of liquid, but high altitude Himalaya receives monsoonal precipitation in form of snow. And because of that, large number of glaciers are sustained there. If you come into the western part of Himalaya, Jammu and Kashmir, Himachal Pradesh, or part of Uttarakhand, you can see that most of the precipitation is coming from westerlies. That means during winter time, there is the systems get developed in Central Asia and they come into the Himalayan region and dumps a lot of snow over there. So they have very different climate sensitivities, and they are responding quite differently for the climate change, and we will look into that issue slightly later on. But it is also for us to understand that how climate change is going to affect this region differently. As we move higher into the atmosphere, particularly into the higher part of Himalaya, one minute. So, so I'm not able to draw it here, but if you look into the Himalayas as compared to the India, so if you take the entire India as a unit and the Himalayas as a unit separately, you will realize that the in the early parts, that means 1950s and 60s, the Himalaya was much more cooler than the peninsular part of India or Indo-Gangetic plains of India. But as global warming started to set up, the Himalaya has become much more warmer than overall India. What it means is, as you move into the atmosphere, the effect will be magnified. It means if there is a cooling effect, there will be more cooling in high altitude. And if it is a rise in temperature, the temperatures will rise much more higher. So if we are talking about 1.5 degree rise in temperature globally, it really means more than 2 degrees Celsius rise in temperature in Himalayas. We have to realize that. And so the effect of climate change, particularly on Himalayan cryosphere, will be much more higher. Cryosphere here, I mean the snow and ice, and which also means the water in the form of solid. So in addition to that, there are a lot of other things that are also happening into the mountain. If you look into that overall precipitation, this work is done by Defense Research and Development Organization. Overall precipitation has not changed, but the component of rainfall has gone up and the component of snowfall has gone down. So it has got the double problem in front of us. That means there is a precipitation in form of liquid has gone up and the solid it has reduced, and the temperature has risen much more higher rate than other parts of the globe. And it is it is creating a issue for a North Indians and having a serious problem on water security issue. So first of all, we must understand how much is the glacial store water there. So we have predominantly three basins in the North India. One is Indus Basin, Ganga Basin, and Brahmaputra Basin, and all these three basins are supported by snow and glacier melt. And that is why these rivers are perennial in nature. If we all know that our rivers, particularly Krishna or Godavari or Kaveri, they are not perennial in nature. We have constrained time to make it water availability, but we don't receive a precipitation during summertime when there is the highest need is there. But in case of Indus, Ganga, and Brahmaputra, there is a snowfall either during winter time or sometime previous year's snowfall, which remains there in form of glaciers, mm, and it melts during critical summer time. So the rivers are perennial in nature. Throughout the year, they have water, and making it, that is the reason why there's a really flourishing of civilization along the Indo-Gangetic plain. So if you look into that in Indus River Basin, it is approximately 2,000 cubic kilometer is the total water stored in the glaciers. Around 596, that means approximately 600 cubic kilometer in Ganga Basin, and around 900 cubic kilometer in Brahmaputra Basin. So there is a huge amount of water stored there in the form of snow, and it is slowly melting as and when you need it much more. In addition to that, there is also large concentration of seasonal snow into Himalaya as well. If you the recent work carried out by Indian Space Research Organization or ECMO, there's another international agency, suggests that at the peak of winter, approximately 1.5 million square kilometer area is covered by snow, and it is almost 85% of the Himalayan terrain, and the summer it is a 10%. That means a 75% change in area of snow cover takes place as we move from winter time to summer time. So there's a large variability of snow cover into the Himalaya, and large area melts. Of course, the thickness of snowpack is not very large, but it is a major source of water for all these rivers, and this also can, it may not change over a period of time in a total quantity, but it is significantly going to change the seasonality. That means as temperature becomes warmer, many models suggest that there will be increase in precipitation, but some of that precipitation will be in form of liquid. It means it will be, if it happens in winter time, then you are going to have runoff in winter. That means there will be change in seasonality of water availability, and we have to look into that, how it is going to affect the existing infrastructure, or we need to augment the existing infrastructure to make use of this changing seasonality. So if you really look into the glaciers, what are the glaciers? Glaciers are nothing but the mass of ice which is slowly moving down the mountain. So this is the Pindari glaciers. You can see here the Pindari glaciers as of now, and it was in 1930s, 1936. It is the full area is of glaciers, and most of the glaciers have gone now, and glaciers are restricted in very high altitude. There are some other pictures also you can see is the Samudra Tapu glacier, where I have traveled many times in past, and some of the people who are participating in this might have come along with me also to do that. So Samudra Tapu Glacier is one of the largest glacier in a Chenab River basin, and you can see that within the 3 years, how much area is lost, and there's a significant reduction in area is taking place. So we should not be under impression that whether Himalayan glaciers are changing or not. They are indeed changing, and we should be very careful about that. So, how that changing snow and glacier, if we take it, that how this is going to affect the vulnerability of the people who are living into the mountain. If we want to understand the vulnerability, this is the work which I was also part of this work, and last year published in Nature, which suggests that how to estimate the vulnerability um, of any river basin, and it is a function of various things. That means how much water is available at the source, then how much water is required by the community, how the communities are going to change in future. That means whether there will be increasing population or there's a stabilization of population. What will be the need of society after some time in future, and whether we have enough governance, and that means whether there's enough scientific governance to address those changes. So the is an issue related to governance, issues related to the societal need, and issue related to availability of water. So if you look into all these three aspects, then you will realize one. You can see here that Indus Basin, which is shown here in is a blackish stone. You can see here is highly vulnerable to change. And if you look that into relatively, Ganga and Brahmaputra basins are relatively less vulnerable, essentially because most of the Ganga basin is partly in India and partly in Nepal, but transboundary issue is not there very serious, and a large amount of precipitation in these basins receives from Indian monsoon. What it means is even if glaciers reduce significantly, it will not have as much stress as you are going to have in the Indus basin, because Indus basin is not completely dependent on snow and glacier. It is a 60% water dependent upon snow and glaciers, and because of that it is more vulnerable. So what are those issues? So if you look into some of these pictures which suggest that how glaciers are changing, this is one in Patagonia, and you will also know that how glaciers are losing mass in Himalaya. It is also very important for us to understand that the loss in glacier mass. What is the mass? Mass means how much snow is accumulated onto the glacier and how much it is melted. Snow and ice is melted throughout the year. So most of the glacier, if you now we are trying to concentrate into the Indus River basin, because Indus River basin is highly vulnerable. We have seen it in our previous slide, and we will also argue a little bit on that later on. So you can see here Satluj basin, Bias basin, Ravi, Chandra, they have almost lost from a 10 to 11 years time frame almost 16% to 6% of their glacial store water. Alaknanda, Bhagirathi are of course in Ganga, and Chandra, Ravi, Bias in Satluj River basin. So glaciers are losing mass is almost 16% in Satluj basin is a large mass considering a 10 years time frame, and 17% in Bias is also very large mass. So if you look into this overall dependence of the river system for its water on snow and glaciers, you will see here that red says that very high, that means 75%. The region which is here, which is close to glacial terrain, and it's part of which is a part of Indus River basin, you see very high, 70% water is coming from snow and glacier. If you come into the Ganga basin, it is significantly reduced, 10 to 15%, and Brahmaputra basin is also significantly reduced. So what I was saying to you earlier, the available data suggests this thing. So we need to understand how climate change is going to affect the cryosphere into the Indus basin. So you can see here that how spatial distribution of this mass loss is taken place. And then another key thing is happening. Even though if you look into the previous slide, that is a 10%, 15% mass loss, but that is not the uniform throughout the glacier. It depends upon the where glaciers are located. If you look into the red color in this, whether it is Bhagirathi, Alankaranda river basin, or whether it is numerous river basin in Indus river basin, those glaciers which are located at low altitude are significantly affecting the mass, affecting by mass loss. That means they are losing ice much more faster rate than many glaciers which are located in very high altitude. We also have to realize that how this is going to change in future. So this is a recent work which is published in this year, clearly suggests that if you take into the Spiti Basin, which is a part of Indus River Basin or Satluj River Basin, you can see that most of the glaciers, large number of glaciers, where almost 60% of glacier disappear by middle of century if RCP 4.5 takes place. I'm sure some of you will have, you may not be having background of representative pathways, but what it means that how in future temperature and precipitation will change. There are some ideas on that, and no one can predict how society is going to change in future. Therefore, um, therefore, there are different pathways. They have said ideal pathway is 2.5, where people thought that temperature precipitation can be managed up to a certain extent, but it is very unlikely as of now, because we have already crossed certain degrees Celsius rise in temperature, and as well as carbon dioxide in atmosphere has also gone up. So most probably we can take RCP 4.5 scenario. Under that circumstances, 60% of glaciers will disappear by middle of century, and by end of century, almost another 7-8% will go. What it means? It means that let us look into the small villages in Himachal Pradesh. This is a small Kyamo village located in Spiti Basin in Himachal Pradesh. And adjacent to that, this is a small glacier which is there. We had gone there last year to understand what can be done to that. And these glaciers are most vulnerable because they are they are likely to melt very fast. But remember one thing: even though these are traditional houses, but they are very prosperous communities, because they generate agriculture, which is in a small scale compared to what we can see in Kolhapur district or that matter in any other place. But their value is very large because they generate the seed grade agriculture. So these are very prosperous places. Some places there are apple orchards, some places they have peas, so many other high end products are produced there. So we need to look into the alternate source of water. It does not mean that region will not have water. It means the present system of water distribution may not function properly, and we definitely need additional investment and new adaptation strategies needed there. In addition to that, there's a whole idea of ice stupa is also there. That means what really happens is if you have large geographical area where snow is melting, and that snow, as we say, that snow, because of warmer temperature, snow has started to melt in winter itself. And if it is melting in winter, there is not enough agriculture can take place in downstream, which is not far away from the snow field. So what do you do with that? That means that whole snow will melt in summer, winter itself, and there's no water available in summer. So in order to address this issue, this whole idea of ice stupa is was created particularly into the Ladakh Himalayas, and you can see here you create a stupa here, and so large the snow which was distributed in large geographical area, and as it melts, it brings it because of the gravity you bring to the pipe, and then you create a certain amount of fountains out of it, and then it will freeze. And once it freezes, it is a small geographical area and it cannot melt so fast. So you can generate certain amount of longevity for this melt. So there are already 26 stupas has been created, and a lot of people are trained in Sikkim, not in Sikkim, in Ladakh, and 7.5 crore liter water is conserved, and government has identified 50 new sites, and the work is going on. But there is also need for us to do more science in it, because whatever is applicable in Ladakh may not be applicable in Sikkim or may not be applicable in so many other places, Himachal Pradesh or Jammu and Kashmir. So we have to be a little bit more based upon, we required a more scientific investigation to understand under what conditions this ice stupa can survive and how long they can survive. So this investigation needs to be done in future. In addition to that, this change in seasonality of water, that means more water is going to melt um, in a winter time, and more liquid water is available in a monsoon time. Change in seasonality can really affect the profitability of hydropower plant. So this is a recent work which is done which is done to understand how profitability of hydropower plant will affect in future. There are two hydropower generation are there with low flow and high head and high head and high flow and low head. So if you have a one condition where flow is low and you have high head, then consistent power generation can be generated. However, in other conditions, variability in power production and improvement in profitability is possible in warm climate. So what really we need to look into now is the designing of hydropower plant, how we can design our power plant in such a fashion that its profitability can increase in future. So these are the issues you need to address and look into that in future. Uh, but as glaciers start retreating, they create a certain amount of risk for the people who are living into the mountains. So one of the such risks for the people in mountains is a formation of lakes. So as glacial retreat, you know that glaciers flow is not parallel to surface, but it is somewhere is inward at top, and it's coming out in a lower reaches, so creating a certain depression onto the bedrock. And if glacier retreats beyond a particular point, then the depression will be filled by water, and these loose moraines can give away sometime and create a flash flood into the valley. There could be various reasons for such flash flood. That includes a cloud burst can take place in the region. There could be avalanches. There could be landslide, moraine melt, or earthquake. There could be various reasons for that, and it can create a serious flash flood. But we have to really look into those issues, and there's a lot of attention of scientific community has gone into this to understand how we can do it. First of all, the easiest thing to do is to map these lakes, which is possible by using remote sensing technique. You take the latest satellite images. There are different semi-automatic algorithm, or you can do visual interpretation and map such lakes. And this is the lake mapping is done in Alaknanda Valley, where recently the flash flood was done. It is also possible for us to understand where new lakes will be formed in future. There is a new tool which is developed here at the Devecha Center, which can predict where these new lakes will be formed. It will not only predict where the new lakes will be formed, but how much this present lake can expand in future. That means if we look into this South Lonok Lake in Sikkim, as of now, it is a 60 million cubic meter of water, and when it is fully blown over a period of next decade, it can become a 90 million cubic meter. Remember, it is a huge water, and it can create a serious repercussion for the people who are living the downstream. So this is a new threat, and there are certain scientific ways people have tried to look into that how frontal moraine can break, and how that frontal breakage of frontal moraine can create a flash flood. So it is possible for us now, by using a different modeling technique, to understand is a flow path and how much is velocity. If you know the volume and flow path, you can easily calculate its hazard intensity, and this is precisely has been done here to showing that which region will be affected. So there could be a mitigation strategy for that, or there could be adaptation strategy for that. So there's a lot of work is scientific community is doing. So all our decision has to be based upon scientific understanding to make it. But there are also new threats which people earlier never realized is going to are taking place in mountain. And in month of May, there was a flash flood in Rishiganga Valley, which suggests that development of fissure in glacier ice. This is a photograph which I have taken in Spiti Valley. You can see here the fissure is developed, and this is a hanging glaciers. And the similar fissure was also seen in Rishiganga before the flash flood. You can see this entire flash flood has entire um, this ice mass has fallen down. It is not only ice mass has fallen down, but it is along with that significant amount of rock also came down, and it took this path like this, and it has created a serious issue downstream. And that serious issue essentially had taken because the huge development of hydropower station was taking place. The villagers doesn't live at the river bed, they live much higher altitude, but hydropower plant has to be at the river bed and creating actually completely washing the Rishiganga power plant, as well as significantly affecting Dhauliganga power plant as well. So it is scientifically possible for us to assess that in future if we become more sensitive. That means we know how much slope is possible. We are using certain tools which is developed by people where the velocity and depth can be estimated. By using satellite images and models, we can estimate how much is the water stored into these ice masses. So in this particular case, it is 6.86 million cubic meter of water was stored in it. It has come down heavily at the slope of 39 meters, which is quite a steep slope, and more than kilometer it has fallen down, creating, you can see here, it is some of these, and it has a 25 million cubic meter of volume. If you can look into this, it is around 7 million cubic meter in ice, but total volume came down as a 25 million cubic meter, suggesting that there's a lot of rocks have also come along with this fall and creating a major flood hazard. So these are the issues. Similar issues we can look into, not necessarily identical in what we see here, but in a different form. We can see in either in Konkan or we see in Western Maharashtra where the huge landslide is taking place in this place. So some innovation can go into it for us to understand the weaker planes in combination of remote sensing technique as well as the field investigation can help us to understand the weaker planes, particularly at places where communities are living, and understand how they are going to affect. So it is feasible to undertake such kind of work. But as it goes, there can be a future risk also, because as the water flows, it dumps along with side. There's a lot of debris and creating a temporary lakes and that. There's also another source of risk in Himalaya, and this is there's a huge outpost of Indian Army was affected because of this major landslide, not landslide, snow avalanches, and we have to. There is already a separate institution of Government of India, Snow and Avalanche Study Establishment. Of course, it is now merged with others, but it is responsible for providing early warning for the people who are living there. So you can see here, this is a powder avalanches. The avalanches means is a rapid movement of snow along the slope, and you can really do that. And some of the avalanches are taking place because of the formation of cantilever structure. We will not go into depth, but you can see here that how this ice slab is hanging, snow slab is hanging over here, and it can fall down anytime and create the avalanches into the downstream. So, what are the risks in a cryosphere? Is a flash flood from hanging glaciers and landslide, flash flood from glacial lakes, snow avalanches, differential glacier mass in Indus Basin, an early melting of snow and vanishing small glaciers. So these are the major issues which community is going to fail, and that can significantly affect the security of the mountain community. So with this, I would like to stop here and take some question if if somebody is having. Yeah, thank you very much.
Thanks a lot, sir, for a very nice presentation you did. If the participants are having any questions, they can ask. In a chat box, they have given a few questions. I would like to ask you on behalf of them.
Sure.
As you have mentioned so many things, and what would be the impact of the climate change on Himalaya, cryosphere, and all that regarding that. So what are the challenges if we have to assess the runoff in the Himalayan basin? So what kind of challenges we were having regarding to the climate change? At the same time, the temperature, which is increasing by 1.5 degree or 2 degree when we are going to consider the Himalayan region for that.
See, one of the key difficulties, is there are manifold issues. The first issue is, of course, the risk of mountain communities. But if you look, if you keep this aside and take the important issue of water availability, then let us look into those issues one by one. So if you look into the very high altitude into the mountains, the communities are living at small glaciers. They are not living at a big glacier because nobody lives adjacent to Gangotri glaciers because temperatures are extreme, weather is extreme, and it is not possible. So people are living adjacent to small glaciers. So those communities will be significantly affected in future because the small glaciers are going to vanish fast. And as glaciers are going to vanish, maybe by middle of century, some of those small glaciers, the ice field or snow field, which is going to take in winter time, are not going to sustain itself for long enough. That means to protect the livelihood of those people living into the small places, we have to find some adaptation strategies. And these responses are different in different places. That means what is going to happen in Ladakh may not happen in Spiti Valley, may not happen in so many others, in Ganga Basin, different. So there's a huge spatial variability is taking place, and we need to understand this spatial variability very clearly and making it very difficult. Another key difficulty which I see is some of my colleagues who are there can tell you is trained manpower. There is not enough trained manpower in the field of glaciology as of now, essentially because it is a hard subject. That means you need to go to mountains, spend months in a mountain. So when you can earn easy life sitting in Bangalore or Pune and Mumbai, who wants to go to the mountains? So that is another issue. But coming to the scientific side of this story, another thing is going to come is how there is a significant change in seasonality is going to take place. That means whatever water is available now in summertime will be available in wintertime. And it is going to change the way we distribute water in the communities. And that means we require additional investment there to make water available to communities in a time when it is not available to them. In addition to that, there are going to be huge challenges in the transnational issue. Remember, all these basins, like take the basin of Indus Basin, which is originating in Tibet, coming from China, coming part of that is originating India, but partly originating China, and eventually going into the Pakistan. So what really happens is when this Indus Treaty was signed between India and Pakistan in early 16, nobody has clue about the cryosphere. That means nobody knew how many glaciers are located. And probably my first glacier atlas of Himalaya, which I published in 1991, then only we realized how much is the glaciers, how many glaciers are there. Of course, we know now. Nobody has clue. So the way water treaty is formed is not a balanced treaty because of the lack of knowledge at that time. So now the climate is responding, these glaciers are responding differently, and it is going to create a transboundary issue. So are we going to have a new way to look these one of these important treaties which is taking place internationally, and that is why there is also a problem in international treaty in Brahmaputra and Ganga with the India, Nepal, and Bangladesh, essentially because we do not know for sure how this future water availability is going to change. And the third point, particularly I would like to say for the civil engineers, is most of the models which is developed, whether you take a numerous model you see which is used for hydrological estimation, they do not account much cryosphere into it. That means all these models are using cryosphere as a land use, and the dynamic nature of cryosphere is not accounted for that. Therefore, the models are producing very limited information as of now. I'm sure it is a matter of time before these models are really updated and we will have a good information of that. So these are, I think, is the challenges which I see as of now. I, if there are any other questions, I can take.
Yeah, a few questions I'm having in the chat box. Pratiksha Sarkar, she has also posted one question. Is there any way to manage this huge volume of water? Because temperature increase cannot be controlled. That is regarding to the disaster resilience. How we can create such type of disaster resilience, because we can't control, that is the temperature increase. So how we are going to manage the huge volume of water?
Yeah, yeah, absolutely. Because there are two facets in this story. One is the mitigation, and the mitigation is a global phenomenon, and that means globally we need to address. But another is adaptation. So how to increase the resilience of the communities? There are different ways to do it. You take one of the risk. It may not be possible for me to take the all risk, but one of the risk, like what we have seen in recently Rishiganga Valley flash flood, or if you can see the earlier flash flood which has taken place in a Kedarnath temple, or before that there was a flash flood in Himachal Pradesh coming from Paruchi Lake. All those things. So it is possible for us to have a multi-hazard early warning system. We may not able to predict which very high reliability that when this disaster is going to take, but it is possible for us to provide early warning to community to make sure that they are aware of this. Suppose we have a strategically located early warning system, which is a multi-hazard system. That means essentially we required the change in stream. There is a sudden increase in a precipitation somewhere. If there is a sudden increase in river runoff, all those things we should be able to relay to appropriate time, and we can calculate how much warning is available for you, whether you have warning for 10 minutes, whether you have warning half an hour, depending upon where you are located and which region is giving this flash flood. So this kind of resilience is possible, and I think one of the key aspect research is going on now to how to create this multi-hazard warning system, as well as how to disseminate it to the community so that at least human life can be protected. There are other types of hazards, they are slow in nature, that can be addressed quite differently. but there's a need to make population more resilient to changes which is taking place. Yeah, sure. Yeah, okay.
One more interesting question I'm having in a chat box, that is the Lakhan Pal, he has asked, on what extent paleoclimate reconstruction is helping us to predict future glacier retreat?
See, what it means is it is very interesting um, for us to understand the paleoclimate. Let me say one thing, in when this whole idea of climate change started to take place, and the rise in temperature is no small, like 1.5 degrees. We know now in summertime in places like Kolhapur or Mumbai, it can go as high as 45, 46 winter time. So we are resilient for 20, 25, 30 degree temperature drop and rise. So what about 1.5 degrees Celsius temperature rise and go? And but if you look into the paleoclimate record of the Earth, and a last a million years record, and which was done by having a deep drilling in Antarctica, or that matter, other you can have a much smarter paleoclimate records if you are using tree rings or any other thing. So this tells us that Earth in past has experienced the changes in its climate, and the glaciers have expanded and shrunk during that time. But present case is much different than that, because at that, when there was a peak of temperature rise on Earth, Earth has carbon dioxide is not surpassed more than 320 parts per million. Now we have around 420 parts per million. So it has given us the understanding that the present climate change is due to human interference. That is the first clue for us. So the paleoclimate has given us understanding that this is not kind of deglaciation, glaciation story, but this is a different story than what we have seen in the history of Earth. So, of that extent, it is very useful. When it comes to the specific locations, if you want to develop, it can really like paleoclimate can give you glacial mass balance. People have used, people have generated large series of mass balance of glacier in the last 100 years, 150 years, which is not possible. So some of the, because the instrumentation records are not that large, it is possible to get the past records and then try to link how it is going to project in future. That is one way of doing science. I think these are the issues we can, paleoclimate in that sense is very important for us to understand. It gives the confidence. Otherwise, all your finding will be model finding. So another clue I can give you is you have two ways of looking at it. One is the climate models, and one is a paleoclimatic archives with a multi-proxy, it could be. So if we generate it for 100 years, and if your model can predict past 100 years change in climate properly, then it can predict next 100 years properly. So it is something which you can do. The models, you can use your models to validate if you have a good paleo history with you. So I think these are the issues. I think we can, if she is not satisfied, we can discuss this further. She can email me, and probably you can get my email on my site.
Yeah, definitely, sir. One more question we are having from Pradeep Purandare, sir. We are talking about the interlinking of a river. On that basis, some of the basins we have basically identified as a surplus basin, as well as some of the basins we have identified as the deficient basins. So would it be prudent to go ahead with interlinking of rivers?
See, it is it is a more of a more of a, because whole idea that some basins are surplus itself, in my opinion, we are looking at the river basin in the eyes of human society only. That means I need it, therefore it is a I don't need it, therefore it is not surplus. I don't have, therefore it is not surplus. I I feel that no river basin is surplus, essentially because if there is a water, what surplus it means is probably more water going into the ocean. But it has created a new certain ecosystem into the estuaries. It has created new, and a large amount of population depend on it. So I will give you an example, not of Indian, but it was done in Philippines, where people thought that they can create a big dam on a river which is a perennial river, which flows the downstream, and divert the water and creates a big rice field. And some of the Philippine rice is very high end, and it is exported very high. But when you do that, because there is a water, you created canals and you diverted the water. But you have got the more water, more rice, but the river's flow is abstracted in such a fashion that the supply of fish which is coming from the sea and entering into that river system and going high and providing fish source of fresh fish to the population around it is completely reduced. And the fish being a high source of protein, there is now deficiency of protein into the population. So we have to look into all this issue much more holistically. Like I will give you an example. Uh, we have so many power plants into the Himalayan river system. You take into the Satluj, and if you start from Bhakranamal and go upstream, you'll see there are hundreds of hydropower plants are there. They all are supposed to be environmentally friendly. It means they are run of river. That means the water is diverted from one place, taken into the turbines, and again drop into the river. So at least you have a patch of few kilometers which is completely dry. And you can see now that many places, because of lack of water, there is a significant increase in landslide have taken place. I have some slides which I don't want to, I'm not shown here, but when I was visiting last time, there are a huge amount of landslide is taking place because bed is completely dry, and suddenly there's a lot of water comes in a monsoon time and it becomes dry. So it is a fragile system it's creating. So I think we should look into the holistically in this issue, and there's a availability of water needs to be addressed a much more different way than diverting water from one river basin to another river basin. Of course, some is inevitable if it is a completely desert area and we want to do it. It's a completely different ball game. But by and large, I think we need to look into the holistically and then come to solution where there's a really surplus water available or not.
Thank you, sir. Only the last question which we are going to take, that is which is being asked by Jyotiram Pishte, sir. Your lecture was very informative, and most of the things regarding to the Himalaya, what would be the scenario that you have explained very nicely. But we are also having the concern that is for the peninsular rivers. So what are your observations regarding to that? Because we can see now recently that the intensity of rainfall that is also increasing in some part, and we are also observing the flash flood, pluvial floods are much more common nowadays in Maharashtra also. So regarding to that, what kind of observations you are having, and what kind of adaptation strategy one should have to deal with this?
See, I have personally not worked into the peninsular India part. My work is predominantly into the Himalayas. But having said that, some of the observations or some of the prediction we knew around 20 years back, when one of the classical papers of Goswami and others was published around 15 years back, it suggested that in future there will be change in the monsoon. It means there will be a more, short duration rainfall, extreme rainfall will take place, and the other portion, that means slow rainfall portion, will significantly reduce, and there will be extreme rainfall will be for, and that will be shorter period. That was new for we knew for last 15 years. But what we don't know how it is going to impact us, because there was not enough scientific investigation, because we thought that Sahyadri is a very stable mountain which is um made of basalts and very strong rock, and it is not there. But the combination of the development activities and some sort of geological reasoning, which is may not be same at everywhere within the, Professor Piston was better than me, is causing this extreme condition where flash floods are coming. And top of that, the development activity doesn't take into the account what will happen in extreme case scenarios. Real problem in all models. Models are designed to provide you information if there are no extremities. And most of the hydrological models are not predicting extreme events quite properly. So, and because of heavy development activities, some of the floodplains of rivers are also occupied. Some of the fragile regions of mountains are also occupied, or there's a development demands by which we are compromising with some of the geological aspect which has to be accounted for um, while constructing roads or any other development activity which is not probably done essentially because the financial reasons are also equally important while taking the decision for any policymakers. So because of that, this is going to happen. So my take, because I am not expert in this area, but my take is we really need a trained manpower more than what we have today. Today, I don't think there are enough um, um, human resources available with us for us to address this problem, which is happening everywhere. Whether you Konkan, whether there are different set of problems in Kolhapur, there are different sets of problem in Chiprun, there are different sets of problem everywhere. And then that will require quite informed decision-taking process. And we require a good, good scientific community, vibrant scientific community to give proper information to the policymakers. Because I remember I had long back, I was when the IPCC was in peak discussions, and when the and 2007 there was a the IPCC said that Himalayan glaciers are going to vanish. So Jairam Ramesh was then minister at center. So I had a meeting with him, and he told me, Professor Kulkarni, whatever you are finding, you tell me honestly. What I have to do, it is my problem. How decision I will take, it is mine. But I want to know the honest scientific input from you. So that kind of, I think we require to generate proper input and provide that proper input to policymakers, and hope that we will able to convince them that certain key decisions development can go in hand, provided robust scientific information available with them. So I think it is a duty of all of us, those who are in academics, to create this kind of manpower which will help policymakers to take informed decisions. Yeah, and that much
Thanks,
only I
sir.
can say.
Yeah. It was a very informative presentation, and all the queries raised by the participants you have answered very nicely. We are very much grateful to you for that. Now I request our Honorable Vice Chancellor, Professor D.T. Shirke sir, to give his remarks.
Today's speaker, Professor Kulkarni, has thrown light on the situation in Himalaya, the issues which are happening over there, the ways to recover some of them, and so on and so forth. I just bring his attention to a typical slide. I could have asked this as a question, but maybe in the first, second, or third slide, where the Himalaya is getting warmer, and the graph shows, I think you have already taken an account of so many years. So maybe at the beginning. Yeah, same. So I can see here somewhere around 1976 or 1977, the things started changing. The situation started changing. May I know, at least this is an inquiry, what could be the reason to get the process reversed? Because later on, maybe the next about 30 years, the trend is increasing, and that too with a high intensity. So what could be the reason to have this process reversed during that typical period of maybe in 76 to, you can say, 86, 10 years, in between something happened and it reverted back for some time, maybe 2 to 3 years, but later on it consistently going high and high. So may I know what exactly is the reason?
See, it is also has to do with the way, because since the Industrial Revolution, the carbon dioxide has accumulated into the atmosphere, and it is during that time it was around 300 parts per million or something like that. But it takes, but in order to have the greenhouse effect, it is. If something happens in oceans also, that means if there is an increase in carbon dioxide, some of the carbon dioxide is taken by oceans, but there's a limit up to which ocean can take it, and a lot of that then remains into the atmosphere. So the process of increasing, even though it started much earlier during the Industrial Revolution, and then there is a huge most of the other countries have started to become also industrialized and more carbon dioxide pumped into the atmosphere. It took some more time for it to react, and then it started to affect in mid 70s or 80s. The first IPCC report started to come in mid 80s or something like that, where people started to phrase that climate change, warmer temperature is global temperature is going to is happening. Some of these findings could be artifact of data also. What it means is this is if you can say it is a temperature anomaly. So what it means is it is taken from 1951 2016 is a mean. It is not taken from, and how much it is deviating from mean. So that mean is not for much older than that. It is not last 300, 400 years. So some of that is coming from artifact. Some of that is coming from the way carbon dioxide and greenhouse affect the interacts with the atmosphere and temperature-rise the experiment. Yeah, that I could see the explanation. This is work done by Indian Institute of Tropical Meteorology.
Great. I think the correlation between CO2 emission and this fact, I think, is obvious. And I think IPCC also has been giving more stress on this particular fact. Maybe in many years also, the situation will be much more horrible than what is there in the past.
Yes,
I think,
sir.
yeah. I just take 2 important points from your session. Of course, every point and every slide is very informative. I must appreciate that. Of course, on behalf of the whole lot of audience, the two things I really want to take it from you is the first and very first thing is that the trained human resources are not available, and we will have to put a lot of efforts in making this generation, at least students of the masters and even the UG, and of course the doctoral students also. We have to train them for this kind of modeling and prediction and so on and so forth. That is number one. Number two would be a sophisticated computer software need to be developed once the manpower is trained. Otherwise, we may have to depend on others for getting this kind of thing. That could be a second. And the third is, I suppose, is a kind of a local thing, which perhaps would be of more interesting and more in which we are more, you can say, is that the prediction of landslides by using a remote sensing techniques. I think that is one of the areas where we, particularly academicians of this region, have to bother about it. And I hope that some of them would definitely look into this particular area. And the academic, I think the departments, colleges and university departments will look after in putting this particular thing into curriculum, so that should be more interested in this particular aspects, and it would be easy to train them in the for further techniques and so on and so forth. I think a lot of analytical thinking and a lot of modeling, the study of models is very much required. Of course, that invites sound knowledge of mathematics also, if I'm correct, sound knowledge of all other related to mathematical ideas also. And slowly the curriculum of subjects like geography, geology, and so on and so forth, they should import these ideas from the domain of mathematics, so that training would be easier. Otherwise, we'll have to start from the scratch, and then it would be difficult. And by that time, maybe some of the students may lose their interest also. So thorough change in this particular system is required, in academic system is required. It is not that only one paper or two papers. I think the whole curriculum should be designed in such a way that the required manpower will be available after having gone through the process of the learning. We should appreciate the talk by Professor Kulkarni, and we really look forward for his visit to our center in the near future, so that there will be a lot of discussion, face-to-face discussion on the issues that this region is facing. Thank you on behalf of university. Thank you.
Thank you.
Thank you, sir.
Thank you very much.
Thanks
It will
for... Yes,
it will be a pleasure and honor for me to come to Shivaji University, my alma mater, and it will be great joy. Sure.
Welcome, sir.
Thank you, sir. Now I express my formal vote of thanks. I am very much grateful to Anil Kulkarni, sir. A very informative lecture he has given, that if the climate change which is happening, and within 20 years, if the temperature is going to increase by 1.5 degree to 2 degree, what will happen? What kind of the scenario we can see in the Himalaya? So I'm very much grateful, sir, on behalf of the Shivaji University as well as on behalf of the center. I'm also very much grateful to Honorable Vice Chancellor, sir, Professor D.T. Shirke, sir, for chairing this session, as well as all the support which has been provided by him to establish the center. I'm also very much grateful to Pro Vice Chancellor P.S. Patil, sir, Registrar, sir, Nandodekar, sir, as well as Dean of Science Faculty, R.K. Kamath sir, as well as all the authorities of the Shivaji University. I'm also very much grateful to all the participants because we have got a very good response for this lecture series. So to all the students as well as the faculty members of various colleges as well as the research institutes, I should express my deep sense of gratitude. And I declare that this session is over. Thank you. Thanks a lot.